My mic went off when I was trying to explain the isomers of hexane. So that's why I'm doing this short video to cover up that and maybe one or two things to go along with it. So isomers of hexane, we said this is C6H14. Yes, isomers means that they have the same molecular formula, but different structural formula. That's what isomer is. So if we want to get the isomers of hexane, how do we do that? We go by, first of all, longest carbon chain, which is 6. 1, 2, 3, 4, 5, 6. Yes. And then you can see it has 14 atoms of hydrogen. Because it has 14 atoms of hydrogen and carbon is tetravalent by nature. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You can see that. So these are the structural formula. This is meant to be H, here H, and here H. This is hexane. How do we get the other isomers of hexane? By reducing the carbon, the longest carbon chain. Here it is 6, so I will reduce it to 5. 1, 2, 3, 4, 5. Reduce it to 5. That one that I cut off, this I've cut off, I will not put it here. If I put it here, my longest carbon chain will still be 6. So I'll place it on the second carbon. I will not place it on the terminal carbon. I won't place it here. I won't place it here. I either place it here or here. So if I place it here, remember 1, 2, 3, 4. That's 5, 6. This is 1, 2, 3, 4. 1, 2, 3, 4 is tetravalent. 1, 2, 3, 4. 1, 2, 3, 4. So this is what we have. So we can see here, if we count, the number of atoms of hydrogen is 14, carbon is 6. So this is 2-methyl. The longest carbon chain is 5, and this is 2-methyl pentane. I'm done with that. You can see from here. Yeah, so the next place is still maintain my longest carbon chain. I'll still maintain my longest carbon chain as 5. Now, instead of placing the branch on the second one, I move it to the third one. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So this is what we have. When you count your carbon, it will be 6. Count your hydrogen, it will be 14. Still having the same strong molecular formula, but different structural formula. So we can see this is 3-methyl pentane. I'm done. So I still see if I can have my longest carbon chain as 5. If I move it from here to here, longest carbon chain will be 2-methyl pentane, giving me back what I already have. So with that, I'll see that there's no need still having my longest carbon chain as 5. I will reduce my longest carbon chain to 4, having this as 4. So if I have my longest carbon chain as 4, I'll place one of the branch here and place the other branch here. 1, 2, 1, 2, 3, 4. These are already 4. 1, 2, 3, 4. 1, 2, 3, 4. So you see that by this, you see your carbon is still 6. 1, 2, 3, 4, 5, 6. Hydrogen is still 14. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yes, so this will now be 2, 2, no, this will be 2, 2 dimethyl butane. Yes, then I will still maintain my longest carbon chain as 4. Move one of the branch here and move the other branch here. If I do so, you still have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So if we go by that, H here, H here, H here, you space it when you are writing. Space, please, space them. When you count, you find out that hydrogen is 14, carbon is still 6. So you see us having, or should I space it? Let me not tell you to do something that I'm not doing. Let me do it. This will be, yes. So if I place 1 here, one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What do I say? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Can see that. So this will be 2, 3. If I come from here, 2, 3. If I come from here, 2, 3. So this is 2, 3 dimethyl butane. That's my answer. Yes, if I try to reduce it from 4 to 3, I will still get back. There's no way, but there's no, yes, I'll get back what I have gotten before. If you try to say, let's make our longest carbon chain to be 3, place 2 here, that's C, and then you have another one here, and then the fourth one, where will I place it? I place it here. If I end up doing something like this. So you see that at the end of the day, I will be having my longest carbon chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now my longest carbon chain will be 4 on carbon 2, 2, which is 2, 2 dimethyl butane. I'll be getting back what I've already gotten. So that's why I will end here. I'll see that my this isomer so far will be 1, 2, 3, 4, 5. 5 isomers of hexane. Yes, that's how we solve that problem. Very, very easy. So sometimes you are even given to you're asked to from the problem, what are the isomers of this part? You just look at the one that makes sure that they all have the same number of carbon, especially the number of carbon when you are asked as objective questions. For instance, they give you 2-methyl butane, they tell you pentane, they say 2,2-dimethyl butane. You know, when you are writing, there should not be any gap between this and this. Yes, butane, and you have 3-methyl butane, and they ask you to tell them the one that is not an isomer. Let's see. This is 1 and 4. That's 5. This is 1 and 4. That's 5 carbon chain. This is 5. But this is 1, 2 plus 4, 6. So this one is not an isomer. That's how you identify that when you are asked problem. You know, on objective, you see, it's very easy. It's very, very easy. So that will be it, because I noticed that while I was doing that video, my mic went off. So I had to redo this little one. We'll call it a day. Bye.